Works? Okay. Hello, everyone. Well, it's very nice to see you. Thanks a lot for coming, and welcome in both offices. This afternoon, we're going to present you a few words, just short stories about machine learning in our company. As many of you probably knows, Bolt tries to solve the problems of the future of transportation. So related to that, we have many challenges, especially related to machine learning and building infrastructure for that. So please welcome Elizaveta, that will tell you a bit more about A/B testing with machine learning models.
Thank you, Lukasz. Hi, everyone. I'm Elizaveta, and I work as a data scientist at Bolt. Today, I will talk about experiments in data science, but first, a couple of words about our company. Bolt, or previously Taxify, we made a rebranding just 3 weeks ago, is the fastest growing ride-hailing company in the world. Now we have 25 million users in 30 countries, and on this chart you can see how fast we have grown during past years. We operate in a lot of countries across the globe, but our main markets are Europe and Africa, and we are number one and number two player on ride-hailing markets in these places. The topic of today's presentations is experience data science, but why I will talk about it today? Because it's a crucial part of product development, of growing and scaling business, as we learned from our own experience. You work in a company, and your company has a product. From time to time, you introduce new features, but doing this, you want to be sure that your changes will be beneficial for a company, that your changes will grow your business, increase sales, improve customer experience, and user retention. And it's what experiments are made for. And it's where data scientists can have direct impact on business. Today, but knowing when and what to look for, knowing potential pitfalls in experiments, it's what makes difference between good product and great product. So today, I will share with you how you can avoid mistakes in experiments, how you can get it right and get results which you can trust. During my presentation, I will share with you what type of experiments exist. I will talk about most traditional A/B testing, about multi-armed bandit-based experiments, and also about tests where you cannot have pure control group. And through all my presentation, I will share with you tips and tricks, how you can not do mistakes and how you can do your experiments in the right way. So let's dive in. But first, question for you. Who of you have ever done any A/B tests? Okay, so many people have experience with that, great. But for all of us to be at the same page, let's start from a basic. What are A/B testing? It's a control randomized experiment with at least two groups, control and treatment. And the goal of this process is to measure and quantify the impact of considered variable. So A/B testing, it can be also A/B-N testing. So you are not limited only for two groups. You can have like one, two, three, or even four groups during your experiment. And you can do it not only like for product features, you can also apply it for design, for user interface, and also for machine learning models, where you just working with your calculation of time parameters and trying to improve accuracy for your model. To better understand what it is and why A/B tests are not so easy as it seems from first glance, let's consider an easy example. You know, in our app, we have a button, select both. It means that you wanted to make an order. And let's assume that once upon a time, we decided to change the color of this button because we think that it will increase the number of rides made by users. So we run simple tests for a new color, new user interface, and we wanted to increase the number of rides. We split all our users in control treatment group in proportion 80-20. So we decide that 80% of people will see old design and they will see like this old curve button, and 20% of users will see new curve, new design. We run this experiment for some time, and after that we measure what was the average number of writes in these groups. And we plot this beautiful chart. We can notice that treatment group has a higher average number of writes. So who of you think that we should now roll out new design for everybody because it has higher number of writes? This time not so many hands. Something fishy here, yeah? Maybe like from your undergraduate statistics course, you remember that mean and average don't tell the whole story about your data. So you should look at something else. And also you probably remember about such term as standard deviation, variance, confidence intervals. So statistics tell us that we also should look at confidence intervals. So what is the variability of this number of writes in confidence intervals? And we can plot it. And here you see in confidence intervals for number of writes in confidence treatment group. And also you see that they overlap with each other. So it tells us that we cannot be sure that there is a statistically significant difference between number of writes between these groups. So in this really easy example, if you would stop on this stage, you would make a wrong conclusion, which would lead you to wrong results. And just adding some additional informations help you to understand better. But now you see that it's not really easy, but something else could go wrong during our experiment. We considered number of writes, but are we sure that it's a right metric to look at? Maybe conversion is more appropriate metric, which would tell us about improvement provided by the design. Or maybe it's a time which user spent from search to make an order. So we didn't consider that one. Next, to calculate statistical significance of tests, we use p-tests. And if you will Google t-tests, you will realize that there are dozens variants, dozen types of this t-test. Are you sure that we choose a proper one? Or maybe it's a wrong one which gives us wrong results? Also, in this simple example, we didn't look at number of users which were in control treatment group. In case if it would just 50 users and 200 users, it would be not enough to make a proper conclusion. So our test will not be tested. It's not all, something else would happen. What if some other team launched its own experience at the same time? What if they also, by accident, choose the same split, 80-20, and by change, they choose the same randomization? So just because of all these coincidences, our effects that we discovered will be not because of our changes, but because of their changes. And again, wrong conclusions from this result. Next point, which could happen, it's a flicker users. What it is, it's a situation when the same user could end up both in control and treatment group. It can be in case when you start your experiments, user had Android phone, but then after a couple of days, he decided to buy iPhone, let's say. And so previously he has on one platform, he changed the platform, and he was in control group and end up in treatment group. So we didn't check if we have these users, because if we have such, our results will be not valid. Now we see that generating numbers is easy, but generating numbers you can trust is hard. And now let's look what you can do to have results which you can trust. Thank you. The most important part when you do your experiments, it's the metric which you choose. And the main advice here, choose only one main metric for experiments. for your experiments. Obviously, you can have different metrics, and you should monitor and track all the different metrics. Because if you look at different metrics, you can easily catch if you have some bugs. For example, you choose like as a main metric conversion, but you also look at distribution of your users across countries or across platforms. And if you notice that there are like 0% of users from like Android OS, you will discover that there is some bug, and as soon as you see it, the sooner you will like maybe stop this experiment or fix some error which occurred. Next. If you have only one metric as a goal, your decision-making process will be much clearer and much easier. Let's imagine that you decided, oh, like 3 different metrics are equally important for you. What will you do if 2 of them increase by 10% and one of these metrics decrease by 30%? So like you will do some trade-offs probably, but it's not really easy and really hard to make a conclusion. Next point is that if you have many metrics during your experiment, your false positive rate will increase. It means that you will notice that there are some difference between your control treatment group, but in reality there will be no any difference. I will not go into technical details why it happened. Slides will be available afterwards, and you can change this link, which nicely describes the reason for that. And the next point about metrics is that proportion metrics are more recommended. So such metrics like a conversion, for example, because in many situations we more care not about like how much user do something, but actually if user do something or not, which is a proportion metric. Speaking about metric types, there are 3 main types of metrics that you can choose for your experiment. It's a continuous metric, proportion metric, and ratio metric. Continuous metric, it contains only one numeric value. As an example, it can be gross bookings per user, or it can be number of visits that user made during the day, or it can be number of orders which user made during the time of their experiment. Proportion metric, it has only one binary indicator value, so 1 or 0. If user sign up or no, if user were activated with some promotion or not. But why it's proportion? Because when you aggregate this metric across all users, you actually receive proportion of users who made something. For example, proportion of users who completed any trips after sign up. Is it clear? Cool. Third type of metric is a ratio metric. Ratio metric has 2 numeric values, numerator and denominator. As an example from right hand, user can have finished trips, and the user also have total trip requests. And total trip requests are usually higher than finished trips because some of trips can be canceled. And when you divide finished trips by total trips request, you receive trip completion ratio. So also here, when you aggregate across users, you receive this ratio. More recommended for experience proportion type of metric, because if you use continuous metric, you will realize that your data have a lot of outliers. So you will see that your maximum value for number of trips for some user will be, maximum value will be like 3 times higher than your median value. That's why when you use a continuous or ratio metric, you should do outlier detection, a lot of cleaning data, but this proportion metric is much easier. So it's just 1 or 0, and you should not, you cannot take into account it. That's why it's more preferable for experiments. Why metrics type is important? Because the t-tests which you used depend on the metric type. As I mentioned earlier, there are different types of t-tests which you can use to measure statistical significance of your test. There are like velocity test, MWW test, history test, and all of them are already implemented in Python libraries or in R libraries. So I will not go in like particular formula how they are calculated. Just for you to know, if you have, for example, proportional metric, you should use a he2 square test. But if your metric type is ratio and your sample size is small, you should use both bootstrap and t-test. We talked about metric, and the next point is sample size and power test. Before doing your experiment, you should understand how big groups or how long it would take for you to detect some percentage of change difference between control different groups. So you should understand how much users you need to have to get your results significant and to get correct conclusions. And again, formula will be dependent on metric type. There are like also tools in sci-fi libraries, for example, but also there exist online tools like G-Power or experimental calculator. And let's have a look at this last one, Evan Miller. All you need to know to calculate sample size is mainly two values here, baseline rate and minimum detectable effect. Baseline rate or conversion is because I choose conversion, but it can be any metric that you choose for your experiment. So this value you can just easily get from historical data. So you can just calculate what was the conversion during past months across your users and use this value as a baseline value. Also, you need to indicate what minimal detectable effect you want to have. And it means that like the smallest effect that you want to see between control different groups. Also, there are two values here. It's statistical power and significance level. They are related to type 1 and type 2 error. So like what is the probability to make like to have false positive or false negative results. And usually they are like, it's a standard to have statistical power at 80% and significance level at 5%. So you put your value here, let's say based on conversion rate 20%, minimal detectable effect 5%, and you see your sample size. In this case, it's 1,000, but be careful that it's per variation. So if you have control treatment group, it would mean that you should have 2,000 of users in total. What's important here is that you run your experiment with this matrix and you achieve this required sample size 1,000, then you should calculate the difference between control treatment group. Let's say your control group will have 20% and treatment 24%. So the difference is 4%. And you see that you wanted to detect 5%. It means that difference that you discovered in your data is less than it's indicated here. So after you discovered this difference, actual difference, it's smaller than you want to see, you should recalculate your sample size and you will see that it will increase. So in this situation, you should run this longer. Is that clear? Are you with me? Okay. And it's what I feel here. So you should recalculate your sample size if observed difference after achieving it's lower than required. There are some tricks with this power calculation because if you want to detect smaller difference between control treatment group, your sample size, your user number of users that you need will increase much. Also, if you have smaller baseline value, your sample size also will increase. So let's say if conversion rate of users from visiting site to make an order is just 0.001, then if you put such value, it will tell you really high number of users required for experiment. So, and once you can realize that sample size is equal to hundreds of thousands of users, who of you would run experiments for 4 months or for half a year Yeah, no hands this time for you. But in most of cases, you wanted to trade fast. You wanted to see like your changes. Like you cannot wait for half an year to introduce some new feature. What you can do here, you can just maybe choose another metric to track, another metric which would have higher baseline value. Also, you can play with minimal detectable effect. So you can increase it and then your sample size will decrease. But another option, what you can do here, is that you can use multi-arm bandit-based experiment. So we talked about A/B tests, and now we are talking about bandits. To understand what it is, let's imagine we are in casino, and we are in front of this beautiful one-slot machine. And let's assume that some of these machines give you higher payoffs than the other, but you don't know which one. And your goal is to maximize your profit, to have as much more money as possible. So what you do in this case? You try first machine, second, third for some time, and then you realize that machine 2 gives you higher payoff. So you play with it, you firstly explore it, and then you exploit this knowledge. But you have limited amount of money, and there are also machines that you don't know what they are giving to you, and you are trying then machine 4, machine 5, and so on, and also you explore again, and then you realize that, okay, machine 5 actually gives me even higher payoffs than all previously seen before, and you're starting to play with it, and it's how you optimize the amount of money which you gain. It's how bandits work. So the main difference between multi-arm bandit-based experiments in A/B testing, it's how they separate these stages. In A/B testing, you have two separate phases. First, you explore and learn, and then you exploit and earn money with this knowledge. So you define your sample size, you run experiment, and only after you choose a winner and apply this knowledge to real life. But with bandits, you explore and exploit at the same time. So at the beginning of your experiment, you say, okay, I wanted to have a split of between control between group, between options that I show to users, like 50-50. After a week of this experiment, you realize that actually option 1 gives for me higher payoff. It provides this higher conversion for users. So to have less regret, you're going to redistribute more traffic for a winning option. And it's how it's shown here. So during A/B tests, you define your split of users as 33%, for example here, and you freeze the split for the full time of experiment. But during bandit selection, at the beginning the same. You choose like 33% split, but then time after time, you change this proportion of traffic which go with some options, and you try to redistribute it in such a way that it will give you higher payoff and will give you like more benefits than the others. On these pictures, you can see the green area. It's the area which gives you highest value. And you can notice that with bandits, this area is much bigger than with A/B testing. There are different algorithms which are stands behind the bandits algorithms, like epsilon greedy algorithm or conceptual bandits. It's like a topic for a separate presentation, so I will not go into these details today, but I will show to you when you can use the multi-arm bandit-based experiments. The good thing about them is that they can be applied for short tests and for long tests as well. The case for short tests is that when you have small amount of time for experiment during like holidays or promotions, let's say you want to test something on a Black Friday, but you cannot use A/B test here because when you finished your A/B test, you already like don't have any time to exploit this knowledge. So in this situation, using bandits is really beneficial. For long tests, first option wherein to use them is like for automation for scale. It's the same example that you remember we discussed. If you discover that you should run experiment for a month, let's say, you can use bandit here. So you can just set it for like 2 months, and then you can be sure that it will optimize your overall value, and you do not have like big losses, and you actually have higher conversion or more number of orders. So just like set it and forget it, how they say. Another option is you can use bandit experiments for targeting. So here your contextual bandits are used, and they learn uh, rules and then assign the best experience for each customer. So they are trying to find common patterns for users and trying to apply for these users with the same patterns the best experience for them. Contextual bandits is actually reinforcement learning, which stands behind. So all of you who dealt with reinforcement learning also know about contextual bandits. We talked about A/B tests, we talked about bandits, and now let's consider a case, an experiment, when you cannot have your control group. What it means? It means that in real life, there are situations when you cannot have like, you cannot allow that your users will have different experience at the same time. So you cannot, let's say, show different ads for different user at the same time. The case that we had involved is that, we have also driver app, and in driver app, we show for drivers a map, and on this map we display areas which we are like show like drivers to come, because in these areas they will probably have order faster. So like it's like a suggestion for drivers where to drive. And there are algorithm which stays behind this map, and we wanted to test new algorithm, but we could not show different riders, different algorithms at the same time, because then each algorithm will be like influence one another, and our results will be mixed, and we cannot really understand what is the like difference actually caused by some algorithm. That's why we decided to do so-called like interleaf test. How it's designed. We ran experiment for 2 weeks, and we divided these 2 weeks into 1 hour slots. First week on Monday from 7 to 8 a.m., it was our control group, so it was algorithm 1. Next hour from 8 to 9, it was algorithm 2, it was treatment. So we swap hours, like each hour between control and treatment group. But next week, on Monday from 7 to 8, it was a treatment group. From 8 to 9, it was control group. And you can see that each time slot during a week was in control at treatment. So actually, it's just this interleaf test. It's one way what you can do if you cannot have this pure control group. You can come up with some other solution, but the main advice here is to take into account what is actually happening in a city or in like any place when you run your experiment. Because let's assume that during week 1 on Tuesday, it was some like national holidays and day off, so most of the people don't work. In this case, we would not compare holiday Tuesday to usual weekday Tuesday, which is working day. Because in this case, our results will be not comparable with each other, and we could have like not valid data and wrong conclusions. And now to sum up, here is the like main takeaways that I wanted you to remember after this presentation. So, as we discussed, have only one key metric for your experiment. Do a power calculation, so understand your sample size. Also, don't run tons of variants at the same time. So change one thing, measure effect. Change second thing, measure effect. If you will do it simultaneously, you cannot distinguish what was the influence of some particular feature. Next, although today I talked about multi-armed bandit-based experience, but don't overcomplicate your method. If you think that A/B testing is easy to implement, just go with it. If you think that it will much faster, just use a simpler approach and always look at what is the impact and what is the effort that you should put to really have some experience running. Next point is that be careful of launching things because they don't hurt. You can think that you can change something and you just set this experiment and forget and you just come back to it after 1 month. But monitor different metrics and really understand what is going on and be ready to stop experiment as soon as possible if it's needed to prevent some big errors and losses. Last but not least, have a data scientist or data science analyst involved in the whole process. These people who know statistics, who know math, and these people who can interpret results in the right way. That's all from my part. And if you wanted to know more about what we are doing in both, you can check our Medium blog. And now it's time for questions. Thank you. Yep. So the question is there a single metric which you are trying to optimize both? No, like we have a different types, different directions which we are working on, and for like each direction has its own metric which we are like optimizing for, let's say. So it's a different metrics, and it's like different metrics for different types of experiments. But if we do some experiments for the same feature, it will be the same metric. So it's the process to defining what is the right metric. So it's like a discussion and to trying to understand what is more important for our case. We are data-driven company, and like we make data-driven decisions. So we are trying to validate what will be if we would do some changes. There was a question, yeah. Okay. We have a mic, maybe we can.
First, the last one, because the experiment we just divided the group by time. Yep. So from seconds, from is there any rule of thumb in which experiment you use this method? Because, for example, if you start changing the shape of the button every hour, you won't have any conversion.
No, this type of settings is appropriate only in a situation when you cannot allow your users experience different like settings at the same time. So in case with like pair of buttons, you can have this like different users.
Could you bring some examples?
So in this, like as we had here, like for this map for drivers. So if we would do it, our like drivers in one group will influence drivers in the other group. So in situation when your like two groups are influence each other, you cannot like test them like at the same time and should come up with some solution.
No, that's not exactly what I meant. I mean, what kind of metrics can you investigate using this method? So I brought an example of where you shouldn't use it, the button shape, for example, and where you could use it.
I mean, button it's not a metric, so
yeah. For which feature this method is mostly convenient?
So it's a method. It's not for user design or as we discussed. It's for like some algorithms which influence behavior of like users. So because we show this map like to influence driver, like to push drivers to drive to some area. So in this case, when you wanted to achieve like some immediate results, which like real life impact on users, then you can use it.
Understood.
And one more question, probably, or
I have more.
Yeah, we can discuss during the break. Okay.
Thank you for this presentation. Very cool. I have a question. So you mentioned you're data-driven.
Sorry?
You mentioned you're data-driven company.
Yeah.
So do I understand correctly that you're basically looking at the results without trying to understand why?
No, it's
Okay.
we look at numbers, which tells you like what p-values or like statistical significance, but we are trying to understand what is stands behind as well.
Why?
So why?
Yeah.
Because we want to understand what is stands behind all these changes, and maybe we do something wrong, and this result can be with some change.
Okay, good. So my next question would be, have you been thinking about, or are you looking at, because if you look at your market, you're going through multiple cultures. Are you actually looking also for cultural dimensions, colors, location of the buttons because of, I don't know, the religion, whatever? Do you do this kind of thinking also, or it doesn't matter?
Usually we run experiments like in particular city, let's say, and like we don't compare what's happening in Africa to what's happening in France. So it's like totally different countries, totally different cultures you mentioned. So it's just like exploring what's happening in some particular place and comparing.
So the results are also applied and local.
Sorry?
So the results that you get from, let's say, from Africa, you wouldn't apply in Europe.
We do like separate tastes in many places.
Anyone else has any question?
Here is a question.
Yes, the last one.
It talks about finding the optimal sample size for your experiments, but do you agree, like, is it that generally the more the better, when you go wrong with getting the more sample size?
Yeah, like big number, like low of big number, like still valid, but it's the main like point here was that you should not have less users that you need. So thank you.
Okay, so do we need 5 minutes break? Yes, let's have a break. 5 minutes.